So this week we're going to start learning about user-defined methods. I probably have several video demos showing different aspects of this, and today with our first one, which is going to do a calculation, I'm going to try to explain what static means. That might not be real clear to you until later on when we learn how to create our own classes. For this first example, I've modified an example program from your book. So in the textbook, our author, Kate Horseman, has a program that calculates the volume of a cube. And since the three sides of the cube are all the same dimension, that method just takes one parameter. I've extended that to calculate the volume of any box, so it requires the width, the height, and the length. And I've already gone ahead and set the program up, and I have three boxes here, box 1, box 2, box 3, which have a width, height, length, and volume. Again, this is really a pedagogical program. This is not the best way to do this, but I'm doing it this way because we haven't learned how to do arrays yet. So normally I would use arrays, and I'd also use objects to represent the box. So I'd have an array of boxes where each box would have these properties. And again, I even put this method in the box class. So don't worry too much about that. We'll learn that later on. Right now, we just want to learn how to make our own methods. So all along, we've been using the main method for our code. When we create a sort of helper or supplemental method that goes in the same class as main, that will be a static method. And so the syntax for that is to declare the method is either public or private. It doesn't really matter if it's private here, and later on we'll learn about that too, because this really controls access for the method outside of this file, or to speak a little bit more precisely, outside of the class. So since this method is in this file, it's going to be available whether it's public or private. But you do have to put that in, so we'll just make it public. It has to be static, and the reason it has to be static is you're never going to create an instance of this object in the way that you normally do. So let's think about this for a minute. Recall back when I showed you how to do use the scanner to do input. We had to create an instance of the scanner. And we had code that sort of looked like this. I'm going to write this in a comment because it's not part of this program. Scanner, and then the name of my scanner, in equals new scanner. And then in this particular case, the scanner takes a string to create it. So this syntax here that we're looking at, using the new keyword, is how we create an instance of an object, or how we create a new object. And then once we have the object created, we there goes my mouse again, damn it. Then we use the methods on that. So once I have a scanner called in, then I can say in dot has next double and next double, etc. All the methods that are defined in that object's class. So these are methods that the scanner has. Now we also did something a little different. So I showed you how to use the math class as an alternative to creating an object for random. So if we look at this, math.random, we're not creating a math object. We're actually calling this random method off of the math class directly, and that's a static method. So it turns out that math is a static class. You never create an instance of math. You just use the methods. And so the static methods that we're going to create today, and in general in our main, in the file that has our main class, will have that same pattern. And since we're calling them within the class, we don't have to use any class name. So the idea here is that I want a method that's going to calculate and return the volume of a box. and I'm calling that box volume. And one of the things I wanted to show you live, which I didn't put in the code, is how we do the documentation. So I'm going to right-click here and use a real nice advantage of NetBeans. And you can see where it says Show Java Doc. I want to insert, let's see, you know what? I forgot how to do this. All you have to do is start typing it, and it does it for you. So I start the Java Doc block, I hit Enter, and it generates it for me. Okay? Now, the way this works is, I've kind of mentioned this before, JavaDoc is the internal documentation system that you add to your program code, and there's a tool that will extract that and create a nice documentation. And when you go online on the Oracle site to look at the Java information, it's actually all created with the JavaDoc mechanism. So this is really a fantastic mechanism for documenting code and the way it works. And as far as I know, that's the only language that has that. So that's a really great thing that Java does. So let's talk a little bit about what we're doing here. So the first thing is, whenever I write a method, I'm going to indicate in the JavaDoc block what it does. So a method to compute the volume of a box. I could probably say more, given the width, height, and length. That's probably okay. Okay. Now these are the parameters. So I have the width, height, and length. So that's the information that I need to compute the volume of the box. And if you look now at the function definition here, we call this first line the function header. Okay. And that's a shame that doesn't fit on the screen here. Let's see. Okay, so public static, I explained that. Let's move this over a little bit. So this double here indicates the return type of the method. So that means it's going to do a calculation and return a numeric value that's going to be a type double. So it'll be a floating point value, and it'll be in the double format. If you notice here, we have our three parameters. These are the inputs to the method. And a lot of times when we talk about methods, we use a black box analogy. So the idea is that we have inputs that come into the box, and we may or may not have an output. And actually, sometimes we don't have inputs either. So sometimes we have methods that just do things. So this is going to return a single value, and it's going to base that value on the three inputs. So one thing to notice here is that each input has to have a name, and it has to have a type. So I have double width, double height, double length. Now these are called parameters, and so these are just placeholders for when I actually call the method and use it. So right now I'm defining the method, and when I define the method, I use the placeholders to explain how to do the calculation. So if we look down here, I have an intermediate local variable, and this is only local to this program, this method. So this is a local variable here of type double. It's called volume, and I'm saying that volume is going to be the calculation of the width times the height times the length. Okay, so those are my three inputs to my method. It does the calculation, and then this is the return value. And so up here I declared that the return value would be type double. That's why this has to be a double. And then the return keyword says go ahead and send the value out, and that ends the method. All right? So now let's look over here in the code. So that's the definition of my method. These are the parameters, by the way. And so in the JavaDoc, we should really indicate what they are. Now, in this case, they're very clear. So basically, the width, and this is going to be width of the box. See, sometimes the parameters are just so clear, it doesn't really make sense to put any kind of comment here, but normally that's not the case, and so you have to describe what the parameters are. And that's very important because this is the documentation that other programmers will use to use the method and to understand the code, right? And so when you're working in the industry, you're working with people, and you need to write code that's clear and works there. And so then here for the return, we're going to say the volume of the box based on the inputs, or the input values. That's good, right? Okay. Pardon me. Let me drink a little coffee here. It's always good to drink coffee when you're writing Java code, of course. Okay, so hopefully you understand how this works. It takes these three inputs, width, height, and length, multiplies them together to compute the volume, and then returns it as a value. All right. So now let me show you the code. So I set up three boxes, box 1, box 2, box 3. I've used really good naming conventions here. So box 1 width, box 1 height, box 1 length, box 1 volume. I don't really need to have this set because I'm going to assign it, but just as a matter of good practice, I always try to initialize my variables. Okay, here's the call to the method. So to compute the volume for box 1, we call the box volume method that we just wrote with the box 1 width, the box 1 height, and the box 1 length. And then you can see that I do the same thing for box 2 and box 3. And then I go ahead and print it out. Okay, so, and this is using the printf we've seen before. So it's going to show it to 2 decimal places of precision and a 5-character field. And so this will look real nice, almost like a little table. And then notice how the parameter is different there. So here the percentage is box 1, volume, then there box 2, and there box 3. Okay, let's run the program real quickly. Not very sexy, actually. It's just designed to show you how to create these methods. Okay, so there are the 3 volumes for our box, and that's pretty straightforward. And then a couple of things I wanted to show you. I really don't have to do this. I can actually simply return the calculation directly. So I could rewrite this without using an internal variable. There's really no reason to store volume in the method. So I can just say return width times height times length. And then I'll just remove this. And that doesn't really change the understanding of how this works. So that's perfectly acceptable. Okay, you don't want to write sparse code and cause a problem with readability, and that doesn't. Okay, so again, I don't need that intermediate variable. You can see it works fine. Just returns the value of the calculation directly, and there's no need to have a named value for that. Okay. Now, I wanted to show you something else too. I could actually go ahead and insert this call. So I'm going to copy this and replace box 1 volume with the calculation. Now you can see that now the code is going to get kind of unreadable, right? So that's not really a good idea. But I wanted to show you that because this box volume returns a double value, it's just the same as having a double literal here where I had the number in there, or where I had the value that already had the calculation. So again, let me run this, and you can see that it still works. Okay. Now, I don't recommend that you do that. As the lines get really long like that, it's difficult to avoid making a typo in the code, and it also makes it less readable. So we're going to put that back. I just wanted to show you that you can treat the entire function call as a value. So this is a double value because box volume returns a double. Okay? All right. That's pretty good for our first example. So real quickly, let's just look at the syntax again. When we create the method, if it's going to be in the main class, it won't be within the main. It's in the class. So see here, let me jerk this over. There you go. So there's the beginning of my class. There's the end of my class. Here's my function. And there's the end of main right there. So you can't be within main. I don't want to try and create a method within a method, all right? And then when I create a method, I include the Java.doc block. And the easiest way to do this is write the method header first, and then let NetBeans generate this part of the block. So let me say a little bit more about that. I have an @param, that's a keyword, and a space, and the name of the parameter. And I have to have that for each one of the parameters. And then if I have a method that returns a value, then I'll have an @return. And I should have a little comment explaining what each one of those things is. And then the only other part of the Java.doc block is the description of what the method does. I usually put a space in here like this for readability. Okay? So you should get in the habit every time you create a method of generating the Java.doc. That's definitely a requirement for any code that you write for the course, and it's just a matter of good best practice. A lot of times when you're working in the industry, you're going to have very strict coding guidelines about how you write your code, how it's formatted, and how it's documented. And the reason for that is that facilitates people working together efficiently. Okay? All right, so this is our first example of a simple method, and we'll do a couple more demos to show this. And one of the things I intend to do is to refactor one of the previous demos that and use a method to make it work a little bit better. Okay? All right, I hope you're enjoying the videos and they're useful for you. And you know what I always say, code on, dude.